Hi people! Today's video is going to be about oxides and making salt. So learning the objective, we have three in total. You need to define oxide. Second one, you need to classify oxide in terms of acidic oxide and basic oxide as well as neutral oxides. Also, you need to combine the separation method knowledge with acid and base knowledge that we learned last week. In the end, you need to describe how to actually make salt and gather them up. Oxide, they're a compound that has oxygen and another element. For example, you have a metal combined with an oxygen. That is a basic oxide. We call it basic oxide because they react with acid. So basically, base is a kind of chemical that react with acid. They're a group of base. On the other hand, we have a group of non-metal element combined with oxygen, and that is acidic oxide. The reason we call it acidic oxide is because they dissolve in water to form a kind of acid. So acidic oxide, they are a kind of acid. For example, for the basic oxide, we have usually magnesium, which is a kind of metal, right? If you burn it in oxygen, you will have a bright light as well as forming magnesium oxide. For the dilute hydrochloric acid, it will usually turn blue litmus paper red. And if you put some copper oxide in there and stir it up, apply heat to it, you will have some copper oxide being undissolved at the bottom, but still, this whole solution in the end will turn litmus paper blue, which means that this solution is not acid anymore. The acid has been react with my copper oxide, which is a basic oxide. Acidic oxide, they dissolve in water to form acid. Firstly, we have a non-metal combined with oxygen, remember? So for example, if I have a sulfur burning in oxygen, that forms my gas. Or on the other hand, if I have a copper burning in oxygen, that forms my carbon dioxide. If I put in water, that forms my hydrocarbonic acid. So that's a kind of acid as well. It's called hydrocarbonic acid. So here's a new challenge for you. Will blue litmus paper change color if you put it into a solution of phosphorus pentoxide? So firstly, blue litmus paper will usually meet with acid to turn it into red, right? So let's take a look. Phosphorus pentoxide, what is that? Let's write that down. You kind of see oxide. It must be a kind of oxide. But pento is just a prefix that tells you how many oxygen do we have in that compound. And penta, this Greek prefix tells you the number is actually 5. Phosphorus, there's no prefix in front of it, so it's only 1, right? So as P, 1 phosphorus, and O5. Usually when there's only 1, we do not put a prefix 1 beside it, just for it is. And the second topic we're going to talk about today is about making salt. Remember yesterday we were talking about acid and base? Well, right now we have several methods of making acid and base. So we have firstly, we have something, either metal or alkali or carbonate, react with acid. That forms, all three of them will form salt. In the same time, metal will give me hydrogen, alkali will give me water and salt, and carbonate reacting with acid will give me not only salt but also carbon dioxide and water. So salt is a very useful chemical compound that people usually want to get. It is something that is either a metal ion combined with a non-metal ion. So for example, I have a sodium, which is a metal ion, combined with a chlorine, which is a non-metal ion. And also I have a magnesium ion combined with a non-metal ion, carbonate ion, that's another non-metal ion, that forms my salt as well. But how do we get them? It's kind of not very easy, not very hard, but it connects to what we've learned in grade 9, which is separating techniques. So if you take a look at it, we have filtration, crystallization, distillation, fractional distillation. So let's go back and take a look at how do we get the salt from all these experiments. If I'm starting with metal reacting with acid, remember this will form my salt and hydrogen. For example, if I have zinc, put it in my dilute sulfuric acid. And then usually I will put more zinc in there to just to use up all the sulfuric acid. So I will have some unreacted zinc. I need to use one of my separating techniques, which is called filtration. So you need a funnel, you need a filtering paper, and you will filtering out all the solution which has salt, and then that will form a kind of crystal, which is my salt. In here, which is my zinc sulfate. So in here, I have zinc reacting with dilute sulfuric acid. That gives me zinc sulfate and hydrogen. Hydrogen gas is a kind of gas. It escapes the solution really quickly. So in here, I have my crystals, which is my zinc sulfate. On the other hand, we have another solution to make salt, which is using alkali reacting with acid. I would use something called indicator. I will tell you why we want to use it in the end, but right now just follow me. I have this indicator. If I put it in sodium hydroxide reaction, which is a kind of alkali, it will turn pink. And I will add acid from burette. Using burette is a good way to slowly adding acid bits by bits, just a little bit, tiny little bit, a little bit, and the solution is still pink. And then just adding one more drop, just one tiny more drop of the acid into my base solution, the pink color will suddenly disappear. That means this solution is neutral. Okay, right now I have water and I have my salt in this solution, right? But there's something else in this solution that I don't really want, which is my indicator. Remember, my indicator is still in here. So what we want to do is that we take a look at the amount of acid that we've used. Okay, for example, 30 milliliter, we write that down. Okay, for this amount, maybe for 30 milliliter of sodium hydroxide, I use 30 milliliter of acid to neutralize it. I write down both of the data, and I repeat this reaction once again, but this time I'm changing it. Remember, I have indicator in here, right? And I don't want it. I want my salt to be pure. I don't want those indicator in there. When I crystallize it, in my crystal is not going to be pure. I'm going to have my indicator crystal with my salt crystal, which is not nice. I don't want that. So what I want is to repeat this reaction. Right now, I know the exact value of the acid and the base to make this solution neutral, right? So we have the 30 milliliter of acid and 30 milliliter of sodium hydroxide to make solution neutral. So this time I don't need to add indicator anymore. I know once I add 30 milliliter of acid with a base, I'll get a neutral solution. And voila! I'll just evaporate out all the water, and that forms my salt. That's it for today's lesson. Tomorrow we're going to do a lab. So see you in class tomorrow. Don't forget to put a question on the form. Bye-bye.